Something surrounds you, bombards you, some of which you can't see, touch, or even feel every day, everywhere you go. It is odorless and tasteless, yet you see it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's x-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves or EM waves are similar to ocean waves in that both are energy. They transmit energy. EM waves are produced by the vibration of changed particles and have electrical and magnetic properties, but unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between the crest is what we call wavelength and are measured in meters. Many are tiny and measured in billionths of a meter, nanometers. The number that has a given point within 1 second is described as the frequency of a wave. One wave or cycle per second is called Hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest but the highest energy waves in the spectrum. So as you sit watching TV, not only there are visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch a TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers. The visible light region of the spectrum. Object appears to have a color because EM waves interact with our molecules. Some wavelengths in the visible spectrum are reflected and other wavelengths are observed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected and our eyes interpret this as a leaf being green. Our eyes see the leaf as green but cannot tell us anything about how the leaf reflects ultraviolet rays or infrared waves. Alright, this is Introduction to Electromagnetic Waves. This is your teacher Hiro, and welcome to our first topic in the second grading. Stay on this video and I will walk you through on how to answer your Module 1 with the topic Electromagnetic Waves. Welcome back in our first module, Electromagnetic Waves, for this second grading. Thank you again for staying in this video and I hope you will stay at the end of this video. So I'm going to show you your module. I will walk you through on how to answer this. So Science Activity Sheet Quarter 2 MELC 1. MELC means Most Essential Learning Competency. So our week 1 or module 1 is entitled Electromagnetic Waves. Now we go to our page 2. So this is the page 2 of your module. Now we proceed to page 3, which is introductory message. So you can just read this at your own pace, at your own time. Okay? Now on page 4, this is the thing that you need to answer because we have here a activity 1, and then we have also the activity 2. So on this module, you will answer in your yellow pad paper the activity 1 and then the activity number 2. Don't forget to write your name at the top of your paper, and you have to write also your grading section and then the date you answered the module. And please do not forget to write the subject, which is science, and then you put also module 1, and then if possible you write also the title of your module 1, which is electromagnetic waves. In this activity sheet, I'm gonna walk you through and explain to you one by one on the things that you need to finish and the things that you need to do. So learning competency with code. So compare the relative wavelengths of the different forms of electromagnetic waves. So the support competencies are: discuss the contributions of Faraday, Hertz, Oersted, and Maxwell in the development of electromagnetic wave theory. Second, describe how electromagnetic EM wave is produced and propagated. And last, differentiate electromagnetic waves from mechanical waves. For the background information for learners, have you used your smartphones to check social media accounts or texted a friend today? Have you also ever tried heating your food in a microwave oven? Did you know that these human activities previously mentioned make use of microwaves? Microwaves are electromagnetic waves that carry energy. There are different kinds of electromagnetic waves that vary in frequency, wavelength, and energy. But what are electromagnetic waves and how these waves can be useful to us? For a start, you will learn how the study of electromagnetic waves came to be. So accompanying debit textbook and educational sites, so these are the references that you might use. But there are links that I will be posting on the description below, so just check it out and just simply click on the link. Now let's go to the activity proper. Activity 1. So this is the electromagnetic wave theory, how it came about. So the electromagnetic wave theory is formulated by James Clerk Maxwell and states that an oscillating electric current is capable of radiating energy in the form of electromagnetic waves. But how did this theory come about? You find out. So you're gonna do a research using print or non-print references. That means you can use a book or the internet to find out who were the scientists who made significant contributions in the development of electromagnetic wave theory. You may limit your research to 4 scientists listed below, information that you have gathered from the textbook and educational sites listed in the previous page. So you can use these references right here, or you can visit the link that I pasted on the description below. So just check it out. So this is the table 1, scientists and their significant contributions in the development of electromagnetic wave. So this activity 1, you're gonna write this on your paper, this table 1, you're gonna copy this, and then as you notice on the first column right here, we have the name of the scientist. We have Hans Christian Oersted, we have James Clerk Maxwell, then we have also Henry Hertz and Michael Faraday. On the second column right here, we have the significant contributions in the development of electromagnetic wave theory. So on the blank box, you're gonna write here the significant contributions of these different scientists. Now, after you answer this table 1 box, you may proceed to the questions. For the question number 1, among the scientists who contributed in the development of electromagnetic wave theory, who do you like most and why? You may choose one of these 4 scientists that you like the most, and then you're gonna explain why, okay? Now let's proceed to the activity number 2. Activity number 2, entitled Propagation of Electromagnetic Waves. You are surrounded with thousands of waves which collide with your body, and some pass through you. Most of these waves are invisible, but some can be perceived. The warmth of the sun and the light that you see are just few of them. These waves share similar characteristics, yet they are unique in some ways. These waves are called electromagnetic waves. In your previous lessons, you have learned about mechanical waves, those that require medium to transfer energy. EM waves are different from mechanical waves in some important ways. EM waves are disturbance that transfer energy through a field. They can also travel through a medium, but what makes them strange is that they can transmit through empty space. Radiation is the term used to describe the transfer of energy in the form of EM wave. For a mechanical wave to travel, it must vibrate the medium as it moves. This makes use of some wave's energy. In the end, it makes them transfer all energy to the medium. As for EM wave, it can travel to empty space or vacuum, so it does not lose its energy. This enables it to cross great distance, such as that from the sun to the earth, which is almost a vacuum, without losing energy. EM waves can also transmit with a material medium. They can also transfer energy to a medium itself. When they interact with matter, their energy can be converted into many different forms. With these characteristics, EM waves are used for a variety of purposes. To understand how EM waves are produced and propagated, you're gonna read page 146 of Science 10 Learner's Material, or pages 387 to 392 of Science and Technology 4 Physics textbook, and answer the question below. For those who have this textbook, you may refer to this, but for those who doesn't have, I'm gonna paste a link below for you to check and study, for you to answer these questions below. So for the question number 1, what are electromagnetic waves and why are they called as such? For the question number 2, how are EM waves produced? For question number 3, how are EM waves propagated and transmitted? For question number 4, how do electromagnetic waves differ from mechanical waves? So under the activity number 2, you're gonna copy this question and then you're gonna put in all your answer below. After answering this, you may proceed to the last part, which is the reflection. So you're going to complete the statements below. So you copy this and then you complete the sentences. First, I understand, I don't understand, I need more information about. So you're going to supply all these blank spaces. And that's it. I hope you learned from this video and I hope you will finish this module within the week. So if you have questions, you may also message me in my Facebook page, or you can put in your questions right on the comment below. Thank you.